The
The
topic of
topic
this
of this lec- the topic of this lecture is atomic building blocks. The reference textbook is Richard Van Noort, Introduction to Dental Material, 4th edition. Atomic structure. All materials are built up from atoms and molecules. To have an understanding of the properties of materials, we have to understand the way atoms combine to make solids. Here in the schedule, proton mass equals to the neutrons, but with different charges, where proton is positive and neutrons are neutral. Electron mass is 1 over 1836 with a negative charge. Joining atoms together. When atoms are brought together, they may link by bonds to form molecules. It is called a primary bond. Depending on degree of interaction between atoms, we get three phases, which are gases, liquid, and solid. A phase is a structurally homogeneous part of the system. As we said, the three phases are gas, liquid, and solid. Gas has little or no resistance to movement. Liquid has greater resistance to movement, but molecules still flow past each other. Solid, movement is restricted. Atoms bond together when this results in lowering of total energy. The controlling factor in bond formation is energy, and bond will only form if it results in lowering the total energy of the atoms being joined, which means that the total sum of the energy must be less than the sum of the energies separated. Covalent bond, it is the simplest and the strongest, arise when atoms share their electron by overlapping of the orbits. Bond is highly directional. An example of a covalent bond is H2. Ionic bond. Halogens are elements which can attain an inert gas structure by acquiring a single extra electron, such as fluorine, chlorine, bromine, and iodine. In this figure, sodium, which is a halogen, will lose an electron, leading to a positive charge, and chlorine will accept or take that electron, which will result in a negative charge to reach a state similar to a neon gas. The difference between ionic and covalent bond is that ionic bond is non-directional because ionic bond are a result of electrostatic field that surrounds ion. Metallic bonds. It is the third primary bond. It is usually in solids when there is a large aggregation of atoms. Like ionic bond, it is also non-directional. In this figure, formation of metallic bond showing a cloud of electrons surrounding the nuclei. An example of this is metals. Bond energy, it is the amount of energy that needs to be supplied to separate the two atoms. Carbon covalent bond is the strongest, while carbon-chlorine it is the weakest, followed by ionic bond, then by metallic, where gold is the strongest and mercury is the weakest, which will result in mercury liquidity in room temperature. Formation of bulk solids. Ions are surrounded by non-directional electrostatic field, and it is possible that the negatively and the positively charged ion can find positional arrangement that are mutually beneficial to reach lower energy. Ionic substances such as chloride, nitride, oxide of metals are the basic building blocks to form ceramics, which are a special group to form glasses. It is very stable because of high ionic bond strength and can form a regular three-dimensional network. In metallic solids, a similar arrangement to that of ionic solids, but no strong electrostatic attraction. Metallic solids are held by the cloud of electrons to form the bases of metals. Covalent solids bond form mostly with dissimilar element, so each element takes up an inert gas except with few, like carbon, silicon, and germanium, can have similar atoms. When the elements bond and have reacted, it will be a highly non-reactive towards molecules of the same type. Bonding will result by sharing of electrons in an overlapped orbit. An example of a covalently bonded solid is a diamond, which is a form of carbon. Secondary bond. Electric dipole is when one end acquire a slight positive charge and the other end a slight negative charge. Van der Waals bond is when a dipole molecule are allowed to interact with one another, forming a weak bond. The three main factors to contribute to these relatively weak interactions are interaction between permanent dipoles, interaction between induced dipoles, interaction between instantaneous dipoles, which are the London dispersion effect. Hydrogen atoms can be imagined as proton at the end of a covalent bond. The positive charge of the atoms are not shielded by the surrounding electron, and they are attracted to atoms on the other molecule. Hydrogen bond is the dipole-dipole interaction. In this figure, an example of hydrogen bond is ice, where there is an interaction between hydrogen atom in one molecule and oxygen atom in another molecule. Molecular solids. Linear alkane are solids formed through a group of molecules. Hydrocarbons are based on a straight chain. The figure represents the four members of alkane family, which are straight chain hydrocarbons following the general formula of CnH2n plus 2. For the arrangement of solids, external forces are needed to move atoms closer together or apart. Intra-atomic spacing is a configuration of minimum energy. The arrangement in this figure is said to be crystalline. The structural arrangement of atoms in solids. Crystalline and amorphous. Crystalline is the densest packing of atoms when they are arranged in a regular symmetrical manner. Amorphous is when there is no symmetry on the arrangement of the atoms. Crystal structure is usually seen in metals and ionic solids. Simplest arrangement will be as cube-like structure with a packing factor of 0.54. We get figure B by stacking structural cells one on top of the other. Atoms will not occupy all the spaces of the structural unit. Packing factor is the fraction of space occupied by the atom, and it is measured as the volume of atom inside the cube over the volume of the cube. It is resulted because each sphere occupies only eighth of its volume to structural cells, and there is 8 segments of sphere, just like in the previous figure. Two arrangements are common in metals: body-centered cubic in the first figure with a packing factor of 0.68. In the second figure, we have a face-centered cubic with a packing factor of 0.74. So in summary, ceramics are based on the ionic bond, metals are based on metallic bond, molecular solids are based on the covalent bond and secondary bond.